Morning, everyone. Today we're going to be looking at homework 29A. Oh, this is a goodie. It's made up of free response questions that deal with rate in, rate out from the last 5 years of AP exam. The first one deals with unprocessed gravel. Remember, we generally integrate a rate to find an amount. Keep that in mind as you go through this. So there's G. G of t equals 90 plus 45 cosine t squared over 18. This is the rate at which unprocessed gravel arrives and it leaves by way of being processed at 100 tons per hour. By the way, gravel arrives in tons per hour. Okay, at time equal to 0, there are 500 tons of unprocessed gravel there. So the amount at time equal to 0 is 500. All right, let's take a look at these questions. Find G prime of 5. G prime of 5. That's pretty straightforward. I'm just going to do that on my calculator. All I'm going to do is write G prime of 5, and then I'm going to write the answer to G prime of 5. I'm not going to try and take the derivative by hand. I'm just going to show negative 24.588, and I'm going to give the units as tons per hour per hour. Why is that? Well, remember that G was in tons per hour. So G prime is the rate of change in tons per hour, or change in G over a change in T. And are we supposed to interpret the meaning of this? Interpret your answer in the context of the problem. Okay, so this is the rate at which unprocessed gravel arrives is decreasing by 24.588 tons per hour at t equals 5 hours. 2, or B, rather. That was A. Now we have B. Find the total amount of unprocessed gravel during the hours of operation. So we want to integrate from 0 to 8, G of t dt, because we're integrating that rate. And when I do that, I get 825.551 tons arrive during the 8-hour day. Okay, C. Is the amount of unprocessed gravel increasing or decreasing at time 5? Okay, so amount function. Let's think about an amount function. The amount at time t minus the amount at time 0 equals the integral from 0 to t of, and I think you'll like this, the rate at which it arrives, which is called g, minus the rate at which it leaves, which is that 100 dx. So there's my amount function, and I want to know if amount is increasing or decreasing at t equal to 5. So I want to think about a prime, and a prime of t will be g minus 100. So a prime of 5 equals g of 5 minus 100. And when I did that, I got 98.4141 minus 100. That's less than 0. So the amount is decreasing at time equal to 5. And they ask for work that leads to my answer. And this is fabulous work that leads to my answer. D. D says, and I might need more paper for D, what is the maximum amount of unprocessed gravel during the workday? Okay, so this is the candidates test problem. They're asking for a maximum of the amount function. And I said amount was a of 0 plus the integral from 0 to t of g minus 100 dx. And that initial amount, remember, is 500. So we've got a 500 plus the integral 0 to t g minus 100 dx. Okay, but I want to know when I have a max. So I have to look at the derivative of this function. I want to know when a prime equals 0. So first I have to find a prime. So a prime is going to be derivative of 500 is 0. The derivative of the integral, thanks to the fundamental theorem of calculus, undoes that. And so I get g minus 100. And since I want to know when a prime equals 0, and a prime equals g minus 100, I can say g minus 100 equals 0, or g equals 100. So this is the time to graph g on your calculator, graph 100 on your calculator, going from 0 to 8 with your x's, and then to find that point of intersection. So when I did that, I found that at time equal to 4.923, they intersected. And that's a place where I wonder, is there a max? Well, I also have endpoints to consider. So that's why this problem is a candidates test problem. We've got these 3 candidates, our 2 endpoints, and this possible max location. And we need to show that we're checking with all of them. So I want to know a of 0, I want to know a of 4.923, and I want to know a of 8. Well, conveniently, they told me a of 0 in the stem of the problem. They said that was 500. And what was the amount of gravel that arrives? No, I want to know, I don't know that number yet. Okay, so I still need to find these 2 numbers. And remember, I've defined a as 500 plus the integral from 0 to t of g minus 100. So if I want a of 8, I'm doing 500 plus the integral from 0 to 8 of g minus 100 dx. And when I do that, I ended up with 635.376. Sorry, that was this one, 635.376. A of 8 was 525.551. And so a of 4.923, I needed to find the same way, 500 plus the integral from 0 to 4.923 of g minus 100. So I have to get these values so that I can compare these numbers. This one is biggest. And so with EVT, we can say the max amount of unprocessed gravel is 635.376 tons at time equal to 4.923 hours. All right, so there's the first question. And really, they really want to see that candidates test. You'll notice it showing up in a couple of these problems. It's quite common these days. All right. So, and remember, each of these free response questions, you're budgeting 15 minutes for. So here we are, 2014, and we're still running 5 minutes fast. Ooh, if you can do the problem that fast, you're doing great. Of course, we need to practice these a lot more so that when we read them, we don't have to spend a lot of time thinking about what the heck the question is asking. We can just engage our calculus and show them the work. Okay, 2014, grass clippings. Says the amount of grass clippings remaining in the bin is A equals 6.687.931 to the T. And this is on 0 to 30 days. These are clippings in the bin, or is it the amount of grass clippings remaining in the bin? This is measured in pounds. So this is not a rate. T is measured in days. Find the average rate of change in A. Okay, so for part A, I'm looking for the average rate of change in A. I want A of 30 minus A of 0 over 30 minus 0. Remember, the units here for A were pounds, and the units on time were days. So our answer is going to be pounds per day. And I used my calculator table feature. I typed this into Y1, and then I used the table feature to find A of 0 and A of 30, and I came up with 0.78293 minus 6.687 over 30, which was negative 1.197 pounds per day. Do they ask us to interpret the meaning of that? No, they just want us to provide the units and a number. Okay, so there's part A. Part B. Find the value of A prime of 15. Well, I know what A is, and I don't really want to take the derivative by hand and then plug in a 15, nor do I have to because this is the calculator portion. I do have to understand, though, that they're likely, are they, to be asking me to explain, using correct units, the meaning of this number. So A was the amount of grass clippings in the bin. A prime is going to be the rate of change in grass clippings in the bin at time equal to 15 days. And the rate of change measured in pounds per day in grass clippings in the bin at time equal to 15 days. Yes, and this number was negative 0.1636. So my answer was negative 0.1636 pounds per day. Okay. Sorry, I just want to read A again. A is measured in pounds, so A prime is pounds per day. Yes. Okay. C. C says the time at which the grass clippings, the amount of grass clippings in the bin, A, equals the average amount of grass clippings in the bin, 1 over 30 minus 0 integral 0 to 30 of A. Isn't that interesting? Well, I'm going to use my calculator to figure out what that is. So I get A equals 2.752635108. And then I'm going to graph this in Y2, and I'm going to graph this in Y1. And I'm going to do second calculate intersect, and I find when t equals 12.415 days, this is going to be true. But notice I had to use my calculator twice here, one for the integral and one to solve this equation. There are only a certain number of things that they want me to be able to do with my calculator, and two of them were right there. Here's another, evaluate the derivative at a point. Okay, and part D. Part D says, a linear approximation at t equals 30 is a better model for the amount of grass clippings remaining in the bin for time greater than 30. Use L of t to predict when there will be half a pound of grass clippings remaining in the bin. So we need to write the tangent line equation, and for that we need a point and slope. So I have 30, but I also need to know a of 30. I also want a prime of 30. Well, I found a of 30 already in this problem, so I can import that. So 30, comma, 0.78293. And then a prime of 30, well, just like I did a prime of 15, I'm going to do a prime of 30 on my calculator. But when I did a prime of 30, I got negative 0.05597622123. Okay, so then my linear equation would be L minus a of 30 equals a prime of 30 t minus 30. And they want me to use this model to predict find time, when L, the output, is a half. So I'm putting in a half there, minus a of 30, 0.78293 equals negative 0.05597622123, x minus 30. I did the subtraction, I divided by this, I added 30, and I came up with 35.054 days. Okay, there's problem number 2 for you. Problem 3, 2015. Rainwater flows into a drain pipe. 2015. So R is going in at 20 sine t squared over 35. And those are cubic feet per hour. So that's a rate function. I bet I'm going to have to integrate that rate on 0 to 8. Water is draining negative 0.04 t to the third plus 0.4 t squared plus 0.96 t. Also in cubic feet per hour. And the amount of water at time equal to 0 in the pipe was 30 cubic feet. Okay, let's see what they ask. How many cubic feet of water flow into the pipe during the hours from 0 to 8? Well, for part A, that's integrating the rate. I want to integrate the rate at which water flows in. I do this on my calculator, and I come up with 76.570 cubic feet have entered the drain pipe in the first 8 hours. Okay, that's A. What about B? B says, is the amount in the pipe increasing or decreasing at time t equals the 3 given answer? Well, I'm going to make an amount function. A minus a of 0 equals the integral of the rate at which it enters minus the rate at which it leaves from 0 to t dx. So my amount function then would be 30 plus that integral from 0 to t of r minus d dx. I want to know, is the amount increasing or decreasing? So I want to look at a prime of 3, which means I have to take the derivative here. Well, if I take the derivative of 30, I get 0, and if I take the derivative of this integral, I get r minus d. So a prime of 3 will be r of 3 minus d of 3. And when I did r of 3 minus d of 3 on my calculator, and really, I typed this into y1 and this into y2, and then I went over to my table and I put in a 3, and I ended up here with negative 0.313632. And since that number is less than 0, I knew that the amount is decreasing at t equals 3. This is sufficient reason. You could also say something along the lines of amount is decreasing because d of 3 is greater than r of 3. The amount leaving is bigger than the amount staying. That would also work as a justification. Okay, part C. Part C says the time on 0 to 8 when the amount of water in the pipe is at a minimum. I'm looking for a minimum. Well, when I look for a minimum, I always look at the derivative. We said the derivative was r minus d. And I want to know when that derivative is equal to 0, or in other words, when r equals d. Is going to be a critical point for me. So I graphed this, and I graphed this, and I did second calculate intersect, and I found they intersected at time t equals 3.271658. But remember, we also have endpoints to consider. We've got the amount at 0. We have now the amount at 3.271658 to consider, and we have the amount at 8 to consider. And you may think, well, Mr. Kukla, these are minimums, because when I look at the A prime graph, my A prime graph goes like that. So this endpoint, from there I'm increasing, must be a min, and this endpoint I was decreasing up to that. You'd think that was sufficient. Guess what? That's not sufficient. You need to show them the full candidates test. They really want to see you using this candidates test. So you're going to have to plug these numbers into our A function. And remember, our A function was defined in this way, right? Our A function is defined as 30 plus 0 to that time value of r minus d. They told me that A of 0 was 30, so at least I've got one of those values. But I had to use my calculator to figure out that this was 27.964561, and that this was 686. So the amount is a minimum at that time. I really need to do the candidates test. I really need to do the candidates test. I really need to do the candidates test. As hateful as you may feel it, you need to do the candidates test and show them that the minimum amount in the drain pipe is at t equals 3.271658 hours. Hours. Okay, and finally, let's squeeze D in over here if we can. The pipe can hold 50 cubic feet before overflowing. For t greater than 8, water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. Right, but do not solve an equation involving one or more integrals that gives the time when w when the pipe begins to overflow. Well, overflow means I get the amount to be 50. So 50 equals my amount function. Well, that's the amount that I started with plus the integral from 0 to w of what's going in minus what's coming out. That's one way of doing it. I think I'd stop at that. Oh, you could always split this up into two integrals, but that's all I need. Okay, 3 questions done. Let's take a look at the fourth one. The fourth one is water is pumped into a tank. Ooh, there's a table this time. Okay, so for 2016, we're given a table. Water is pumped in according to W. W is this exponential function, 2000 e to the minus t squared over 20. And those are liters per hour. And the time is 0 to 8. Then water is removed by R. That's also in liters per hour, but that's from the table. I guess I won't be graphing R of t. No, you're not supposed to make an equation of R of t. Stop it. No. Okay. What do they ask us about here? Oh, and they say the amount at time equal to 0 is 50,000 liters. Okay. Part A. Estimate R prime of 2. Show work that leads to your answer. Indicate units of measure. Okay, so R prime of 2 is the rate of change. I want the slope at 2. I don't have a function to plug 2 in, but I can approximate that by using the average rate of change and R of 3 minus R of 1 over 3 minus 1. By the way, this is the work they want to see. You don't need to do anything more than that amount of work to show them. And those values I can take from the table. 950 minus 1190 over 2. And I came up with negative 120 liters per hour, right? These numbers on top are liters per hour. The numbers on the bottom are hours. Watch out for your units. Okay. B. Use a left Riemann sum with 4 subintervals to estimate the total amount of water removed during the 8 hours. Is this an overestimate or underestimate of the total amount? Give a reason. Okay, let's start with LRAM. My first subinterval goes from 0 to 1, and using the left height, I have 1340. Plus, my second interval goes from 1 to 3, using a second height of 1190. Plus, my third subinterval goes from 3 to 6, and I use the third height of 950. And my last subinterval goes from 6 to 8, and I use the fourth height of 740. I end up here with 1340 plus 2380 plus 2850 plus 1480, I believe, for a total of 8050. Yes, you could get away with this as your answer. Is this an underestimate or an overestimate? Well, in the stem of the problem, they tell me here that water is removed from the tank at a rate modeled by R, liters per hour, where R is differentiable and decreasing on 0 to 8. So R is decreasing. So when I think about my LRAM, My LRAM uses the left height. My LRAM is going to be an overestimate. Overestimate because R is decreasing. And just so that you don't think it's about concavity, let's do a concave up function on that interval and see, look, same thing happens. We have overestimate when we do LRAM for a decreasing function. Okay, part C. C says, use your answer from part B to estimate the total amount of water in the tank at the end of 8 hours. Well, amount at 8 minus the amount at 0 equals the integral of what entered from 0 to 8 minus the integral of what left from 0 to 8. And this 80/50 is the amount that I'm approximating left. Remember, A sub O, or A of O, is 50,000. So then I get that A of 8 equals 50,000 plus the integral from 0 to 8 of W dt minus 80/50. When I did this integral on my calculator, I got 7836.195. And so I got that A of 8 would be 49786.195 liters at time equal to 8. Yeah, no justification needed. And then finally, part D. Is there a time when the rate at which is being pumped in is being pumped out? You know, this would be a really easy problem because all they want to know, W equal to R. Except that I can't graph this. I can't even set them equal to each other algebraically. And Megan, don't you dare try and create a function for R of t. That's not what they want here. They don't want you to do this algebraically or graphically. They want you to think about this calculously. And so we know that W minus R would equal 0, right? And so this is the place when the rates are the same. Well, let's find what the rates are at time equal to 0. W of 0 minus R of 0. And when I did that, I got a positive number. And then I checked the other endpoint, and I got a number that was less than 0. And remember those fabulous fists, according to IVT, there must, because W and R are continuous and differentiable, you have to state the precondition now. There must be at least one point when W minus R equals 0, right? Because IVT says we have to go from all the values from this positive number to this negative number, and 0 is included in that. You must mention the preconditions, and yeah, so we have to use IVT because they don't want us trying to build a function for R of t. Okay, so that's 2016, and then the last problem, 2017, bananas. And with the bananas problem, we're told that bananas are added to the display in the store. Bananas are removed from the display. F is the rate at which they are removed. And that's 10 plus 0.8t sine t to the third over 100. And that works for 0 to 12. And this is removed. And the units here are pounds. Is that a rate? It's a rate. That's pounds per hour. And the store clerk adds them at a rate of G, 3 plus 2.4 ln t squared plus 2t. And that's only on 3 to 12. Pay attention to that difference. That's important. Okay. Again, this is a rate. So these are in pounds per hour. How many pounds of bananas are removed from the display during the first 2 hours? So for part A, I want to integrate f from 0 to 2 dt, and I found out that that number was 20.0517 pounds removed during the first 2 hours. Okay, that's an easy 2 points. What about part B? Using correct units, explain the meaning of f prime of 7 in the context of the problem and find f prime of 7. Well, they're not expecting me to find f prime of 7 by hand. This is the calculator portion. And I got negative 8.120 when I did this on my calculator. Remember that f is pounds per hour. And when I take its derivative with respect to time, it's pounds per hour. So this is the rate of change in pounds per hour at t equals 7 hours. C. Is the number of pounds increasing or decreasing at time equal to 5? Well, excuse me. If I think about my amount function as being the amount at time 0 plus the integral, oh boy, this is awkward because it wasn't happening the same amount of time. We were adding from 3 to the time, but we were subtracting from 0 to the time. Ew. Well, luckily, they're asking me at time equal to 5. So remember, if I take the derivative of this, increasing or decreasing, the derivative of this constant is 0, the derivative of this, even though I'm starting at 3, is g, and the derivative of this, even though I'm starting at 0, is f. So a prime equals g minus f, and I want to know a prime of 5, and so that would be g of 5 minus f of 5. When I did this, I got negative 2.263103, and so that meant the amount of bananas is decreasing at t equal to 5. And then finally, part D. Part D says how many bananas are on display at time t equal to 8. Well, so that amount function that I created, they want a of 8, and that's going to be a of 0 plus the integral from 3 to 8 of g minus the integral from 0 to 8 of f. Please note those differences when you type this into your calculator. I ended up with 23.347 pounds at time equal to 8. Sorry, I went off the bottom there. So a of 8 equals a of 0, the initial amount, plus how much was added from 3 to 8, take away how much was removed from 0 to 8. I ended up with 23.347 pounds on the table at time equal to 8. All right, wasn't that fun? Can't you wait? Woohoo! Don't worry, we'll practice lots more of those. But we really needed to get to that moment in time where you started seeing these problems in a significant and meaningful way. Hopefully also you started to note there was a rhythm, a cadence to the problems. They asked about a lot of the same things. The first problem, it was usually a straight integral question. Integrate this rate to get an amount. They asked simple derivatives and evaluating derivatives at points. And generally the last two were, is the rate increasing or decreasing? Is the amount increasing or decreasing? And so we had to look to see if the difference in the rates were positive or negative, and then we had to do some sort of candidates test on absolute min or absolute max, or we had to do an amount at a certain time, and that's our fundamental theorem of calculus question. All right, well, I hope the ASVAB was fun, and those were your homework questions from last night.